Everybody. Today we'll start a new topic. This is lecture 22. We'll talk about a new topic. It's related to multicasting. Multicasting. Multicasting is, I think, is a very important techniques because with these techniques, it's possible for us to enlarge scale distributed system. In most distributed system, usually we need to send the data. Data should be transmitted from one node to another one, and maybe the forward again, such as a peer, they can forward data from this one to another one continually. But I think multicasting is a more efficient way to transmit data. Although peer can transmit data, can forward data from one node to another, it's not so efficient, especially when the scale of the peers or distributed nodes is large. So we need to have an efficient way to transmit the data. That's why the multicasting algorithm or API should be considered. So that's why I want to talk about this topic for this lecture. And because the most important techniques for distributed system programming is to implement the scalable large-scale distributed system. I have mentioned that the most difficult distributed system is the global scale socialized heterogeneous distributed system. That is the internet. So now I want to, so one of the most important topic in grid free is how to handle that, how we can implement large scale distributed system, how we can implement the most difficult distributed system with one particular techniques conveniently. So that's the goal of grid free. So before we can do that, we need to have a multicasting API. So that's why I want to give you an introduction, or that's why I want to explain how grid free handles this important issue. You must remember that in grid free, there is one important concept. I'm not sure you remember it or not. It's called advanced API. We have the concept of distributed API, right? You must remember that we have programmed with distributed API for many times. So this time, but another important concept is advanced API. It's impossible for us to always program with distributed primitive API. Although DP, we can use DP to program anything. However, it's spent a lot of our effort if we only program with DP. So we need to invent some new APIs, that is advanced API in grid free. So we have already created two advanced API. The first one is CS client, right? We talked about this before. And the next one is peer. We program with peer to create a 3-tier architecture, or create a peer to P2P network. Based on this framework, we can transmit data or transmit a file between distributed nodes conveniently. We have done that before. So it's better if we use distributed primitive. It's difficult for us to program the code, although it's feasible. So when we need to create some new APIs, with new APIs, such as multicasting-based API. So we need to the code become if we program with distributed primitive API, it's consume us a lot of effort. So here we need to know how to create such API if multicasting is so important. I need to mention that I need to emphasize that in Grid Free, any API are not implemented using any other third-party techniques. It only uses API from Grid Free if the API is related to distributed techniques. I will explain that in detail for the multicasting API, but you must have some you must have some this such concept when you program with these two simple API, CS client and peer, right? I explained how the peer is implemented, how the CS client is implemented. I talk about one important issue is called aggregation of DP, right? Because we use pattern, the aggregation is not so difficult. Because when you program with DP, there are a lot of patterns besides, in addition to those APIs. So when you program such a system, when you program new APIs, you just use the distributed patterns as well as the distributed API, not just the API. So when you program with such a system, a new API, you can use both of them. It saves you a lot of effort. I have shown, at least we have two examples. The first one is CS client, another peer. So for this time, although the multicasting API become more complicated than a peer and client, you can see that the procedure is the same. Why just use DP plus and distributed knowledge for multicasting. I just use the two part. The first one is two portion of knowledge. The first one is DP. DP should be used, and another we need to the developer that who want to implement the API of distribute for multicasting. It must have knowledge what is the mechanism for multicasting. He need to know the fundamental algorithm. So he need then he can describe such a message with Java. But when they describe such algorithm for multicasting, they do not need to care about the underlying distributed issues. They just have the idea of distributed knowledge. That's enough. They can describe such algorithm using Java language, but this language is not related distributed techniques. They just know some knowledge. They can use some the underlying issues, the distributed architecture, networking, serialization, concurrency. All the issues are handled by the distributed primitives. They just focus on the distributed knowledge description. So it must save a lot of effort of the developers, right? So that's why it's better for us to use Grid Free to implement the distributed system, distributed and as well as the distributed advanced APIs. So in this class, as we have done before, I want to teach students. I want to teach you. You should not only know how to program with a distributed API. But also, you need to know how you can yourself, you can implement a new API by yourself if you need it, right? So because a digital system is difficult, there are a lot of techniques, a lot of scenarios. We need to implement various distributed APIs. So if you encounter such a case, how can you implement an advanced API using existing techniques of grid-free? So that's different from traditional system, traditional programming languages, or at least different from the most popular ones for distributed system programming, such as ICA, Go, Erlang. I made a lot of comparisons at least, but these three ones, maybe another competitor. There are a lot of distributed programming paradigm, but most of them, at least to the best of my knowledge, none of them consider or provide approach for developers to implement new APIs using their own techniques only. That's one most important difference between grid-free and others. So that's why I want to explain a little bit about the implementation of each API if we got a new one in grid-free. So for this class, I will show you two new advanced API. The first one is a root clan. I'm sorry. Another one is a child clan. This is only two advanced API for multicasting in our case. When you program with, I think you need to have some knowledge about multicasting. So multicasting have three different types. The first one is broadcasting. That means the message, the data, multicasted from the root to its children. Maybe the number of children is maybe 100 or 1,000 or 10,000. There are a lot of children. When the message is sent from the root to all the children, if each of them is required to receive such a message, such multicasting is called broadcasting. This is the definition of broadcasting. Anycasting means if the root need to send data to its children, but the procedure of multicasting is terminated if any one of the children receives such a message. If at least one of the children should receive such a message. Only one is enough. Maybe not 1, 2, or 3. That's fine. If it may be all of the children receive the message, that's also fine. So for anycasting, it's not required for each of the children receive such a message. At least one of them receives such a message. Such type of multicasting is called anycasting. Another one is unicasting. Unicasting means when a node needs to send the data to its children, the root of the node specify before the data is sent, specify that one particular node should receive such a data. This is 1 to 1. The root or the sender knows which one should receive such a message. The root must specify exactly, clearly, which node should receive such a message. This case is called unit casting. So when you implement the AA or advanced API for multicasting, you need to implement each of them: the broadcasting, anycasting, and unit casting. I need to emphasize again. When you implement them, all the APIs, when you implement such APIs, all the details, all the techniques used to do that is originate from DP only. You just use DP and in addition to, and then DP plus some description about the algorithm. Okay, so now for our case, in grade 3, I implemented two important basic API, or not a basic, advanced API. The first one is a root clan. Another one is called child clan. You must have this idea, right? Clan is used to send data, right? Clan is used to sending data or message, right? That's the definition of the clan. Clan can send a notification, as we had done before, notification and request, right? This is what a clan need to do. So that's the clan can do that. So why we call root clan? Root clan means that there is a hierarchical structure. Within such a structure, there is a root. The root is a source of messages or data. The unique source. The data is sending to its children start from the root. All the data is sent to its children following the roots, following the parts of the structure, of the hierarchical structure. Usually such a structure, in my system at least, for the fundamental multicasting, tree is a it's the efficient way for us to transmit the data efficiently. Tree is a typical hierarchical structure or topology for us to send the data to a larger number of users, or larger number of distributed nodes, a larger number of children. So that's why the clan, the source of the distributed node, need to have an API to send such a data. So that's why I named such a new API root clan. You must notice that we have CS clan in the previous class. The clan for the DP, there is at least two portions, right? The eventer and reader. The eventer is responsible for sending notification. The reader is used to send a request and receive the response. So for the root clan, that's the same. The root clan also need to send notification and also need to send request. So when the data is sent as a notification, the clan can send such a notification to all its children, or some of the children, or one of the children, in an efficient way. But in such a case, no any response is collected from all the children, because such a message is a notification. However, if the message is a request, if the message is request, we have to send such a request to its children through root clan. At the same time, more important, responses should be obtained. Responses should be collected from all the children that receive such a request. So that's very important, different from traditional such a reader, from the reader of the CS clan. In CS clan, if the one node, the client send to the server one request, and there is a direct internet connection, right? TCP connection between them. So then the interaction can be performed based on the TCP network net connection. There is the direct connection between the client and the server. However, in our case, because there is a tree structure, there is a hierarchical structure, so the data is actually forwarded from one node to its children. Each node is such a, if the node is not leaves, if the node is not leaf, then each node, if the node is not leaf, such a node must have some children. Then each node need to forward the received message to its children, right? Each node need to do that. So it save a lot of effort of the root. If the root need to require to send data to all of children's one by one, it's slow. It consumes a lot of efforts. It consumes a lot of computing resources such as bandwidth, CPU cycles, and even memory. So it consumes a lot of computer resources to do that. However, if the root just need to send some of them, maybe 2 of them, 3 of them, maybe designed by the hierarchy structure, the branches of the tree. If the root has 3 children, then he just need to send data to its 3, but to all the 3 children. It saves a lot of effort. However, for such a 3 branches tree, there are a lot of, we can construct such a tree that contains, in theory, infinite number of children can be contained in such a tree. So each intermediate node, each intermediate nodes have children, and then they can keep forwarding data, right? Keep forwarding data to its children. So that's a way how we can implement. That's a general description about the multicasting algorithm. I don't think this knowledge can cover all the multicasting issues. For some complicated cases, the structure, the hierarchical structure may be not a tree. For some complicated cases, the structure may be a graph or forest. For more complicated, the hierarchical structure or the topology of the maybe is dynamic, is not stable. Maybe the connection always changed. There is a lot of disconnection. There's some new connection. All the graph of one particular topology is always updated. So that case is more complicated. But I think if you use root clan, child clan for one specific, for one small portion, even the entire structure is dynamic, but at a specific cell or at a specific scope or for such large large scale system, for one specific, no. For in one scope, for within such a large scale distributed system, or within a large scale distributed topology, at one specific scope within it, there must exist a topology like a tree. So a highly dynamic graph or topology large-scale highly dynamic topology is made up with a large number of small tree-like hierarchical structure. I'm not sure whether you understand or not. Are made up with a large number of tree-like hierarchical structure. So that means we can, even for a large-scale dynamic computing environment, we can still use the root clan, child clan to construct such a system, to design a highly dynamic cluster, multicasting. Although I believe I need to make some changes. Until now, I haven't implemented such API. I'm trying to do that in the next step. Until now, I haven't do that, but I think the current these two API is useful for you to. It's still useful for you to even in a complete distributed computing environment. At this time, our computing environment is stable. It's not highly dynamic. It's stable. So for stable, and the scale is limited. But at least the procedure to implement such APIs is must be helpful for you to implement a more API, the API that can deal with more complex scenarios. So that's why I want to give you first I want to show some. We can start from simple cases to complex cases. Okay, so this time I will show you how to implement I can implement such API. So first we can start from this one, right? Root clan. Let us open this projects. Open from here. Because we have, I don't want to explain that in detail. I just go through this API. You can see here. Maybe, I think I missed, at least I missed one. Okay. I must have missed, lost one slice. I can make, but it's not, it doesn't matter. I can copy paste because this is almost the same. The root clan, the root can send it should be send, right? Send notification to its children, to its oh sorry, to its directly connected children, right? Because there is a hierarchical structure, tree-like structure, so each root have a limited number of children. So the root just need to send a notification request to its directly connected children. And then the root client, that's idea is very important. The root is implemented with the DP. The most important API used here is SRE. I'm not sure, do you remember the SRE or not? The SRE is represents the synchronous remote eventer, and it's DP means we just use a distributed primitive. SRE is the most we just use SRE to construct the system. So because we need to, however, somebody must ask the question. SRE is we can send a notification synchronously, right? And do we need to consider send this data asynchronously? Right. We also need to send a notification asynchronously. But in this case, I just use another approach to perform send the data asynchronously. So I do not use the ARE, asynchronous remote event. ARE is not employed when we implement multicasting. And another thing is another question maybe you will ask is how to send request. Do we still need to use SRE to send the request? Yes, the answer is yes. In this case, we do not use the reader. In DP, there is a API called remote reader, right? However, in our case, in this case, when we implement the request and the response over multiple nodes, not just two pieces of node. In the previous classes, only two nodes are available for request response. However, in our case, in this case, the data is sent from the root to a large number of children, a lot of distributed nodes. And only the children which have only the children that have a direct connection with the root have TCP input-output stream. TCP input-output stream only exists between the root and its directly connected children. You must understand that, right? If so, it's impossible for the root to get response from the indirectly connected children. It's impossible for the root to do that, right? So remote reader is based on directly network connection, such as TCP connection, right? Direct TCP connection. That is a foundation of remote reader. However, in our case, there are a large number of requests need to send all the children, such as I'm not sure whether you have such idea about MapReduce. In MapReduce, a large number of partition tasks. There are a lot of number of tasks need to be processed by all the childrens in a cluster. So each children need to send a response. However, in such case, multicasting should be employed. However, because they're impossible to construct a large number of connection between the root and all the children, so remote reader cannot be used. We have to use other approach to implement such API. So in our case, there is when we go through this code, I will explain how to do that. You must know renderer point. Renderer point. I'm not sure you. Renderer point. There is a concept called renderer point. Renderer point means within a large-scale distributed system or any distributed system, there is a node called renderer point, RP. We can represent is the acronym is RP. The RP means all the nodes need to send response to such node. So all the responses can be collected and to form a final response. So in this case, each node, each children need to be a peer, right? So peer is very important. We already have the peer. The peer can receive information, and then it can send data to the renderer point. That means forward data to the rest. Forward is generated responses to RP. Right? So in such case, the peer can connect it with the renderer point. And then all the responses can be collected. So that's why we do not use remote reader, because it's impossible for us to establish direct connection between a root to all the children, and because we need to save effort, right? And the RP, what about the number of RP? Usually, for a simple case, maybe the root can be the RP, right? We just for some simple distributed system, we just select one node as the RP. Maybe the root is better. A straightforward solution is use the root as a RP. But if the scale of the system is too large, it's not proper to use a single RP to collect responses, because it also consumes a lot of effort for the RP. So maybe we are a lot of multiple RP are selected, and we can build a hierarchical structure for those RP, and then collect all the responses from bottom to the top. Yeah, from the leaves of the tree to the root. We constructed another topology, a tree-like structure to collect all the responses. This is another approach, right? And this is for complex cases. We have to do that. In this case, this root RP, I already implement two approach to implement the root client and the child client. I already done that. But in this case, the RP is we just use we start from the simplest one to complete one. So this RP, this root client is for our multicasting implementation, the API implementation, we just use a single RP to collect data, to collect responses. However, you can see that you must know that all the issues I just talked about is distributed, is algorithm, is a multicasting algorithm, right? Is multicasting. Did you knowledge about multicasting? So we already have some necessary IP, right? API, right? The peer, the synchronous remote eventer, and the concurrency, right? And so we already have those fundamental distributed related techniques. So you just need to, but if you want to implement a new API, you need to have such knowledge. So what we talked just now is a distributed knowledge for multicasting. Okay, so next, let us take a look at the code. I think I already explained the fundamental concept, so we need to take a look at the code. This is the underlying code. So when you want to implement the program with root client, you don't want to change the code. It's fine. If you want to implement some upper level application only, it's fine. However, I think because I want to approve grade-free, is generic, is self-contained, it has a lot of advantage against existing techniques. That's why I want to explain so many details. Okay, let us go through the code. You can find this code from this package, right? According to the name, you can see org.gray.multicasting.root. You can find this code easy from here. Root client is here, and when you open it, you can see remote eventer, remote reader, and there another API. It's called root sync multicaster. And if you are interested, you can open this code. Okay, before that, let us take a look at because this API already implemented, but there's still some low level code. If you are interested, which I will show you the code later. And you can see here this is a constructor, right? This is a constructor free client a pool, because the data need to the root client is a client, so it need to send data. So free client pool is required. Here there are two parameters. The first parameter is called root branch. Another is called tree branch. Those branch, you can see, because we need to construct it, we need to construct a tree-like topology, because the tree is a fundamental topology for multicasting. Even the most difficult distributed system need to based on the tree-like structure. So we have to start from the tree. The tree branch count means the number of direct connection between the root and the number of direct connected children. And this tree branch means all beside all the intermediate node, in all the intermediate node must have some children, right? The number of such children is defined as a tree branch count. Tree branch count. That's why we need to have such two parameters. Usually, the source of the multicasting, like the root, must have more computer resources. This is in practice. In practical system, that's a one important fact, because this is the source of this is the population, this is the source of the data. So usually the root must have need to have sufficient computer resource, more sufficient computer resources than its children, because it's a source of the children. Maybe it's a website, right? Maybe it's a cluster. So such a root is necessary. Usually, for such a root, it can afford a larger number of nodes than those intermediate nodes. So that's why I want to define and specify. I need to provide a new one specific parameter for the root. So maybe because this number, usually this number is larger than the tree root count, because the root has more computing resources than its children. So that's why I want to do that, right? Another one, wait time. What does it mean? Wait time is used in this case because we need to collect a response from a large enough children, right? If we want to do that, what we can do? It's possible for large-scale distributed system. It's possible for one of the node got failed. So we cannot collect sufficient number of enough. We can, because for example, there may be 100 children in such a cluster or such a distributed system. However, maybe one of the children got failed. When we need to collect the responses, so maybe 99. We got 99 number of 99 responses. Do we need to still wait for another responses? In some cases, not necessary. Maybe 99 is enough. So we don't need that. We just need to wait for some time. After timeout, after timeout is after sufficient certain timeout, we don't need to wait any longer. We don't need to do that. So we need to set up such a parameter, right? Because the large-scale distributed system is possible. It's very possible to get some node cannot respond in time. So we don't need to wait. Thread pool. What is thread pool? Thread pool, yeah, because with the concurrency system, there are a lot of threads need to be managed. So we have to use the thread pool. So that's easy to be understood, right? Okay. This is the constructor. Okay. Next, this is the root sync. Because we have no sufficient time for this class, so we just go through. Take a look at the root client for this class. Next, we'll take a look at this class, the root inventor, root reader, and root synchronous multicaster. Next time we can take a look at this. And this one, we need to close all the computer resources. You can see random point, right? Because we need to collect the responses from children. So we need to have the root is in our simple case, this is simple way. This is the most simple way to implement multicasting. So usually the root is select as the RP or random point. Nearest children K. What does it mean? The root have a lot of children, right? The root manage all the children's. The root is able to have the right to construct the structure. So the root have all the children, have all the K's of the children. So maybe one of the children, if we specify 1K here, and maybe one of the children is closest to this K in terms of string comparison, right? That's important for some cases because, for example, we need to do something to distribute data or assign task to children evenly for load balancing issue. So we can in this way we can select one of the children to do that. Another, if we K update, we can select another children to do some other task. So in this way, with this comparison, if we get nearest children, that is one way for us to assign a large number of tasks evenly. Okay, that's one important. Maybe in the later cases, I will show you how to program with it. Broadcast notification. This one is maybe you can easy to be understood, right? This one broadcast notification. One notification is sent from the server, from the root to all the children. So we need to use notify. You can see this API. You have never seen such API before. Let us open it. You can see here, right? This is a same as notifications request that we have implemented before, because all of the multicasting message have the parent called server message, right? Okay. In addition, one difference is here. The children, the message contain the children IP address. That means if the message is received by one child, the child, according to the message, the current node will know the message, how to forward this message, because all the IP address of the children is obtained from this message. So according to the message, the data can be forwarded according to the IP address contained in such a message. Okay, this is the multicasting. This is a new API, right? But it's originated from DP, because server message is one of the API of DP, right? No anything new in distributed techniques when we implement multicasting API. Okay, there are a lot of other APIs we can send the data in different approach, in different multicasting manner, so we can explain those API in later classes. Okay. Okay, if you have any questions, just email me or give me some comments after watching this video. Okay, thank you so much. That's all for today. See you next time.